And
We're recording.
are we gonna walk through the problem again, or you just gonna explain Davian today?
It's whatever is better for Jordan's blog. Like, you wanna
Yeah, maybe.
walk
Maybe.
through it? You have some more content to like work off.
Okay, so how do we do this?
So we're gonna walk through the problem. So in the past, we're just gonna read the prompt first and try to understand the problem. Then we will walk through the problem. I mean, according to the algorithm method. For this one, because in the past, most of them are using pointer system. So we're just gonna work on like how we move the pointer left and right. Then work through the whole logic. Then we write the steps of the logic of the algorithm in sort of pseudocode or notes. Then
Mm-hmm.
um, then the driver just gonna follow the notes and write out the JavaScript code.
Okay.
Yeah. So do you wanna explain the question, Jordan?
Okay, so just read the question.
Yeah.
Okay, so
Can you see my screen?
yeah, I can see yours. I was wondering like if I should go off your screen or if I should go off the VS Code thing that you sent, or does it matter?
If
Um.
we're in the live share, it shouldn't matter.
Yeah, you
Okay.
are the live share now. Yeah.
Okay. So move element to end prompt. You're
Yeah.
given
Thank
an
you.
array of integers
Told you.
and an integer. Write a function that moves all instances of the integer in the array to the end of the array and returns the array. The function should perform this in place. It should mutate the input array and doesn't need to maintain the order of the other integers. Sample input of the array is 2, 1, 2, 2, 2, 3, 4, 2, and to move would be 2. So to move, I'm assuming, is the integer array, obviously the array. Sample output 1, 3, 4, 2, 2, 2, 2. The numbers 1, 3, and 4 could be ordered differently. So are they saying to like move the array so it's sorted, or
So it doesn't necessarily need to be sorted. What they're
mm-hmm.
saying is whatever the to move value is, any elements in the array with that value need to be on the end.
Okay.
So are you who are gonna uh like explain the question process and write it in the README here? Yeah.
In the README?
Yeah.
You tell me.
So do I write it or?
You can write it. You can explain to the because whenever I explain, it took too long. People sleeping.
I
I'm
did
trying to make
not
sure.
fall asleep. I was
Yeah.
resting my eyes.
So
I can give a hint is here if we use a sorting algorithm, the time complexity will be not as good as using not sorting algorithm. If we don't sort the array, our time complexity will be linear time, then it will be O(n). If we use the sorting algorithm, it will be n log n. So to optimize this solution, if we don't use sorting algorithm, it will be better. Just a hint.
okay.
Yeah.
Sample input the array and then
So
to
who's
move it
explaining?
to.
Do you want me to explain?
Jordan,
Can,
you can explain to Jordan is explaining now.
can, can someone else explain, please?
Okay. So I'm gonna try to do it from memory. I technically saw the solution because I got frustrated and was like, this meeting's about to start, and then I was like, oh, I was so close. So to keep testing myself, I'll just do it from memory.
Yeah.
So basically, it's the solution we want is the one that's unsorted because it will be quicker. It will be less operations. So we'll essentially still have 2 pointers. We'll have one at the beginning of the array and then one at the end. The one in the beginning will kind of act as our like pretend it's like a for loop. It'll be our index that kind of loops through the array. And
Can you
then,
explain on the notes so we can have
do I
like
type it? Oh, I typed
yeah,
it.
we
Okay.
can visually understand better.
I don't know when this navigator driver thing kicks in. Okay. I'm like, who's. Okay. So. This is MD.
Yeah.
Hey! Kick me off.
Okay, so I do see it working. All right, cool.
Okay. So. Well, we basically move all elements that match the move to the, what is going on? Variable. I'll just give y'all some extra lines to like put your cursor at.
Yeah.
That's a root to variable. To the end of the pass in array. So, what the heck? Okay, so what we'll essentially need is 2 pointers. One at each end of the array. I guess we can like I don't know, name them. Just like for me, current index and what was the other one? Like we had it like last found match supposedly.
Those are index number or the element name?
It'll be the index.
Can you name one is I and then another one is J for the index?
I'm gonna rewriting it. You can shorten it. You can shorten it when we get to the function.
Okay. Fine.
If I'm typing, I'm typing. I need to read it.
Okay.
All that I and J. What's wrong with you? This isn't a Myers-Briggs test. We've got I, N, F, J, E, N. We ain't using those letters. No, I'm kidding. Okay, but where was I? So we need a while loop to iterate over. We'd allow while loop to to determine how is it to determine when our current index is greater than our last found match. Okay. So, is someone's mic in a wind tunnel? Okay, I'm hearing things. Okay, inside of the while loop, we have another while loop. Another while loop. Let me try something. That checks when that was a fail. Okay. I tried to get Siri. Siri's like, what you mean? Okay. Another while loop that that checks if the value of our current number is equal to our move to variable. Yeah. It's so hard to do it from memory. So, well, we don't need comments, but like, example, while I is less than j, for you people who like, variable, is equal to our move to variable. Okay. If our current value is equal to move to, we we check how did you look at the function? I'm terrible at it. Wait, where's the function? God. I don't know where it is anymore, so that's it. The current value is equal to move to.
The value of our current is equal to our move to variable is equal to move.
You know what I'm trying to say?
Stop up. Let me take a look.
I can no longer find where my example problem was.
I'm gonna go find.
I was about to say you have to leave the room and go check. I thought. No, you to move to. We check if.
Each of the
we check if.
Check. Okay, so inside the while loop, right? Inside the while, we have another while loop that check if the value of current number is equal to move to variable.
Yes.
Okay, move to variable. If our current value is equal to move to, we check. I think it's check for pointer system. So are we gonna move the current?
We're gonna look for the end pointer and make sure that it also doesn't match move to, and if that pointer does not match, then we swap the positions.
Right.
Why did it take so long for us to say that? Like we all knew it. Okay, so we check.
Wait, so if the first pointer at the beginning of the array doesn't match the pointer at the end of the array, we're swapping?
Okay, so first we check if the pointer at the beginning of the array is a match to move to.
Okay.
Because we want all the matches of move to be at the end of the array. So if the pointer at the beginning is a match, the next thing we need to check is if the pointer at the end is a match, because we don't want to replace a match if it's already at the end. We want to replace the first number we find that isn't a match. So the first number we find that isn't a match, at the end of the array, we swap the positions of those two numbers.
Okay.
And then we continue and then that inner loop finishes, and then the outer loop checks again to make sure that I is less than j, or that our current index is not past the position of our last found match, because the second they swap, it gets weird, and then your function breaks, and it defeats the purpose.
Okay, got it.
Maybe after you write the notes, can you walk through the numbers, like move around for demo?
That's your job. I refuse to do that part. And you get two playthroughs. We are not going to play through the entire thing. You get two loops. That's it. You get two. We're not looping through the whole array. Okay. We check if our end pointer is equal to move to, it doesn't matter. One of them. Move to. If it is equal to move to, then we move our pointer to the left and keep doing so until our pointer value doesn't match. Then we swap the positions of our current index and our end pointer, which then becomes our last found match. Then we increase our current index pointer by 1, and the process repeats. Okay. I'm not as thorough as when Jen writes it, but okay, let me try to. Oh yeah, and then once both loops finish, we return our mutated array with our matches at the end of the array. Okay. So I'll try to do a better job explaining it than typing it. So we're going to start with 2 pointers, one at the beginning of the array and one at the end of the array. Our outer while loop, all it's going to check is to make sure that the 2 pointers don't cross. Once one is bigger than the other, or once they switch places and one becomes bigger and the other becomes smaller, we break out, we finish, the function is done.
Okay.
So while our beginning pointer is smaller than our end pointer, we want to search for values that are equal to move to.
Mm-hmm.
If we don't find a value that matches, we skip it, because we don't need to worry about it. When we do find a match, we then check our end pointer to make sure that it also isn't equal to move 2. If that pointer is not equal to move 2, then we move it to the left. If it isn't equal to move 2, then we found the numbers we want to swap. We swap our current index with our end pointer. Those values switch, and then our our counter on the left hand side increases, and then we start the process again of looking for more values that match move 2. Once our left and right pointers switch places, the loop ends, and our array should be sorted with all of our the values we want at the end of the array. And yes, in a weird way, there are actually use cases where you would need to do this in real life.
Okay.
So now you want some step through, walkthrough, pseudo codey stuff, Jennifer? You're like the unofficial captain.
I don't know if Jordan like this or not.
Does he like it or not? It's not vegetables. I don't care if he likes it.
I like it. I like it.
Does it make sense?
Yeah. Yeah.
Like it?
So I don't know, according to your notes, to do the walkthrough stuff, so you will be more visualized and loop less. So I'm gonna try that, and I'm gonna just put here. Can you guys see?
Yeah.
Okay, so.
So you want a pseudocode now? Wait, did you make another editor?
Yeah. No, it's just.
Oh, you're just a new. Okay.
Yeah, so this time I gonna use your notes to walk through the numbers. Because in future, where in the past, I walk through number first, then writing notes, right? So gonna say, I don't know, like just say walk through. Okay, so basically, according to Davian logic, we first need okay, step 1, we need 2 pointers, right?
Yeah, we just need a left and a right pointer. It's called left and right, or L and R, something like that.
Left pointer, happy? Or you want another name? Or J and I and J. Doesn't really matter.
You can at least do L and R. At least that makes more sense than I and J.
Okay, fine.
Start and end, I, J, left, right.
L and R. Happy? Okay. Okay, step 2. Okay, so
I feel personally attacked.
Okay, we initiate that one. So our original array is like this one. Hold on a second. It looks like this. Then we wanna find something to do with the to move element. The value is 2. So okay, so I'm gonna use that one. So this is our first pointer, which is L left, and this is our last found match pointer, which is called the right pointer. So step 1, we just initial the position of our pointer to be clear. Okay, then I need to take a look my notes. Pointer that one. Okay, so first our left point is 2, right? So while the current, so according to the notes, it says while loop determine our current index is greater than our last found a match. So yes, I smaller than j now, which is yes. So inside the while loop, we have another loop to check if the value of our current number is equal to variable our current is check our endpoint is equal to move to. So that is more like a edge case, right? So right now we are sort of met both conditions. Do you guys agree? So first we check the I is less than j, which is right because our I is here and the j is here. And if current value is equal to move to, okay, so the I value, it is equal to the move to because the move to is 2. Then we check if our endpoint is equal to move to. Then we check endpoint, which is 2. Is it equal to move to? Yes. So we are in this scenario now. Okay. So if it's equal to move to, then we move our pointer to the left. Okay, Davian, I need to question your notes. You say if our current value is equal to move to, we check our endpoint is equal to move to. Okay, so that is, yeah, we check this one is equal to move to or not. If equal to move to, we move our pointer to the left. Which pointer? You didn't tell us. I guess
Only
move
one pointer. Each pointer only moves in one direction, so we move our right pointer to the left. Is what I meant to say.
So now we're gonna move our right pointer to the left.
Yes.
Now our pointer is here, and the left pointer is here, right?
Yes, move our right pointer to the left.
Okay. Then we until our point doesn't match. Okay. Let me see. Okay, I gonna. How do I write this pointer stuff? This one. So, round one. I don't know, like round one. Round one. L equals. What do I say that? Okay, left num is equal to 2. Then right num is equal to 4 because we move the pointer, that one, to the left. So this is the after we move, that is what it looks like. And the pointer left is here, pointer right is here. Okay, then we're gonna do something. After we move, then we're gonna okay, after we move, what do we do? Okay, we swap the position of our current index and our endpoint, which then becomes our found match. Okay, so once we move to the left and we see 4, what is the logic we're gonna swap the elements, David? Because we wanna move all the 2's at the end, right?
Wait, so you're asking how do we do the swap, or are you asking? What are you asking?
Are you guys still there?
I'm still here. Yeah.
I'm asking you to repeat what you're asking me.
Okay, so I understand the.
I'm muted. I'm asking you to repeat what you're asking me. That's what I was asking.
I understand your notes. Yes, I just according to your notes to move the pointer. So right now our left point is here, right point is here, right? Then you say we're gonna swap the numbers. So means
we
gonna
swap the values. We swap the values at the current index.
Yes. So we're gonna now 2 become 4, then 4 become 2. Then
Mhm.
why we swap the numbers?
Done? That's not even done. Wait, so why do we swap the numbers?
Yeah, why we swipe? You like change position.
Well, because we want the twos at the end in this scenario, right?
So yes, because we want the twos at the end, we want to swap the
S-
the
The value,
so
yeah.
yeah so in 0, 1, 2, 3, 4, 5, 6. So 4 is at index, the value 4 is at array index 6. We want to change the value of array index 6 to 2, and then since 2 is index 0, we want to change the value at array index 0 to 4.
Yeah, I understand that, but how does the computer know right now the 2 is equal to the move 2?
How does the computer know?
Yeah.
Because inside of our while loop, we check after every time we move, we check, and then so while I is less than j, we check if it's less than, and then we check if the current number is equal to move to. Once we do move to, once we find that that's equal inside of our while loop, we then do another check to make sure. That's when we start our inner while loop. We check that. This is why I just need to get to the code. So once our inner while loop is after we find a match to move to, and we're looping to find a number in our right pointer that doesn't match move to. So the inner while loop is checking for that.
Oh,
So
got
um,
got. So
okay.
can I write something like this? So we first decision is we need to move the index of right in pointer, right? So can we write if um if like a right element right now is equal to move to then we move right pointer, move right pointer, right sorry, move right pointer to left.
Yeah, right pointer minus minus or whatever it
Yeah,
is.
yeah. Then okay, then we became this one. We became left num is 2, then right num is 4. Okay, then once we did that, then why we swap the number is because swap the number is if the left num is equal to the uh, move to uh, uh, First, remember we are like no, not left num is equal to move to. Okay, so how can we swap the number? Oh, okay. So if the right number is equal to move to, we move the pointer to the left. Then we check left number is equal to the move to. Then we swap the position. Does that make sense?
So left number is
Yeah.
our beginning index. Yeah.
So
So
Yeah.
so
So left number is equal to 2, and because we are already in round 1, means already moved the pointer. So when the left num is equal to move 2, and
so
our right index is here, then if that scenario, then we swap the number.
so when left number is equal to move to, that's when we start our inner. That's when we start the other while loop, and the inner while loop checks if right number is equal to move to, and when the right number is not equal to move to,
We swap.
when the right number is not equal to move to, that's when we swap. But if it is equal to move to, then the while loop keeps going and keeps moving the pointer further and further left until we find a number that doesn't match.
That doesn't match. Okay.
Okay, can I write that? So this need to be if the left number equal to move to and the right number is not equal to move to, then we swap, right?
Right.
Okay, so we need to make sure that one. Otherwise, we don't know why we swap the number, you know. Okay, okay, then we come to this stuff, not like this position now. So right now is here. Right now our pointer is our right pointer. Okay, Jordan, can you tell us where is our left pointer now?
If left num is equal to move to and right num is not equal to move to, then swap positions. So then our left pointer. Wait, so we just swap positions?
So can you tell me the value of our left pointer now? Like
It's after the swap?
Yeah, right now we are here.
Right, okay.
Yeah.
So after we swap, does our left pointer move up at all, Devin, or is it staying?
So our left pointer moves after
Up
everything
one?
else. Yeah, our left pointer moves up one at the end of everything. So whether we find a match or not, our
It's
left,
moving up.
yeah, it's moving up.
Okay. So then our left pointer would be at 1.
Yes. So because our left number would move, if we don't find a match to, if our left number doesn't equal to move to, it needs to move up anyway. So it'll be outside of that conditional. It'll be outside of that.
Okay. So then the left pointer would be at 1.
Okay. First element. Our right pointer.
It would be at 3.
No, it's still here.
The actual index? Oh, wait. I need to scroll down. Okay, so this 2 here is after you swapped the 4.
Yeah. So last.
So it will be here unless we also do another minus, which I might do that.
I can put that one means index 1 because I don't know how to put because it has duplicate value. Okay, then left num is 1, then right num is 2, right? But it is okay. Right num, yes. Oh, sorry. Left num is 1 and the right num is 2. But yes, the last two. So that was the
So the index 6.
Yeah, 6. Okay. Then okay. Then we become something like okay, hold on. Then we become something like okay, we can still use that one. Then what step we gonna do? So right now, left point this one, right point is this. According to the logic we did, yes, we define the position of our pointer now. Then next decision we're gonna check is if the left num is equal to move to. If the left num is equal to move to or not, which is not, and the right num is equal to move to or not. Right now is equal to move to. So that is opposite from that scenario. Then what should we do?
Then it should go back, and then the right pointer should decrement 1, right? Or go down 1? Because we're still in our loop, our while loop. Hello?
He's like, hello. Oh no, we heard you. No, okay.
Oh.
So we're talking about right now because left number the value of left number is equal to 1, and
It's
so
not equal to move to.
and 1
So
is
it's
not equal
not
to the
equal
value
to.
of move to.
Okay. So then we want to move. Wait. So if our left number is not equal to move to, and our right num is equal to move to.
So we don't, at least as currently constructed, we do not check the value of right num until we find a value of left num that is equal to move to.
Okay.
Sorry, what did you say?
So then our left should increment, right? We should move up 1.
So
Can you
we just
cosign on that?
so we just don't swap, right? Because
Yeah.
only met this condition we swap the number. Now it's not swap the not met the condition of this. We just keep on moving on. So we're gonna go our round which round? Round 2 now. Okay, I'm gonna say this. Don't swipe. Do not swipe. Okay, then we're gonna go the round 2. Round 2. Okay, round 2. We're gonna move our pointers now. Okay, hold on. Let me copy this one and paste. Okay, so can someone tell me what is our left num right now? Like what is our left pointer now and what is our right pointer now?
Oh,
Don't can you tell or Davian tell?
I know I could tell I wrote it, but
Okay. Maybe doesn't tell it.
So is our left num still 1 and our right num still 2? We haven't done anything since then.
No.
our right num hasn't moved, but our left num.
Yeah.
has.
So our left number has moved. So now our left number is 2.
No,
Which, or yeah,
so we continue move forward. So we're gonna move our pointers now.
Yeah. So our left pointer moves up 1 to 2, right?
yes, both in
Yes.
value and index. So it's index
Yes.
2.
Yeah.
Okay.
Yep, we haven't done anything with the right pointer yet. Or we should not.
Okay. So our right pointer is still the same.
Our right pointer still the same? Davian, still 2?
Yes, because we don't check that.
Okay.
Or we haven't checked it yet, so it's still
Still
where we
the
left it.
6, like index at 6, right?
Yes.
Okay. That one will be 6. Okay. Now what do we do? So right now, yes, left now we move to the left, right, and our right index is here. Now we're gonna make a decision, right? See we're gonna swap the number or not. Yes, that one. Yeah. So then we're gonna make decision if we're gonna swap the number or not. Then how we're gonna do is we compare the left num equal to the move to, and right num is equal to move to or not. Then according to the above condition here, if left num is equal to move to and the right num is not equal to move to, then we swap. So right now we still don't swap because right num is not equal to move to. Right num is equal to move to.
Mm-hmm.
So that is not to match this condition again, because this condition is left num equal to move to. But right num is equal to move to 2.
Right. So then we want to move our right pointer, right?
Then what should
Correct.
we? Yeah.
We want to move our right pointer down 1, and then repeat the process of comparison, right?
So Davian, yes, your logic is if right num equal to move to, regardless left num regardless left index, we just gonna move to the left.
So we check if it's equal, and if it is equal, we move to the left.
Okay,
Our
so
right pointer moves to the left.
So we're gonna move to, so because I think we're gonna only this condition we're gonna swap the positions. Right now it's not match this condition. So we're gonna move our right pointer to the left, right?
Right.
Oh, sorry, right pointer. Okay, so right now we are like okay, so right now our left num is equal to um okay, when we move the pointer, can we move both, or we need to check first? Which move left pointer first, or we move right pointer first? Davian. Oh, we can move
You're
same
talking
time.
about moving the index, or changing
Yeah,
the index.
yeah.
We move the right pointer first because the left pointer has to move at each iteration, whether or not there's a match. So the part of the code where we move the left pointer is in a different position than the part where we move the right pointer. So the left pointer moving is not conditional, but the right pointer moving is. So the left, that's why we don't move both at technically the same time.
Okay. So right now our left point is 2. So it's in the index left num index 3, not 2.
So
Index
we finished our third round.
no, third round is okay. So third round is our left num is which one, and right now I know right now yes we're gonna move index to the left. So which is 3.
Yes.
Okay, so our left num still the previous one, right? Previous one, which is 2. Okay, here 2. So that is index 2. I think here I got a typo. It's supposed to be 2, right? Okay. Then then okay, now we are like left pointer is here and the right pointer is here. So we compare 2 is equal to move 2. Yes, and the 3 is not equal to move 2. So it's met the condition. Met the condition. Condition. Then swap the numbers. Yeah, so met the condition is now left num is equal to 2, and which is equal to move 2. And right now is equal to 3, which is not equal to move to met the condition. Then we swap the number. Then we become okay. Swap the number. I'm gonna copy this one. Then swap. Copy paste. Okay, so our 2, which is 3. Then our 3 is become 2. Is it right? Okay,
Yeah.
so now we swap the number. Our current index left is here, right is still here. Then we compare. Is it 3 equals 2, which is not? Then are we here? Geez, I kind of
Lost place.
Yeah, we are.
We're there.
left. Right now, left num is equal to 3, right? So that is the index 2.
3.
2.
Wait.
Yeah, and right
Oh
now,
yeah, 2. Yeah.
yeah, right now is equal to so that is the third
2,
one.
which is
Okay,
the
still
fifth.
the 5, still the same index number.
Yeah.
Because
Yeah.
we swapped, yeah. So it's still 5. Okay, then we check. Check. Yes, left noun equals to the move to or not. Move to or not. Which is not. Uh, plus 3 is not equal to 2. Then and uh 2 is equal to 2. So we will not swap the number. Then we're gonna move pointers, right?
We're gonna move our left pointer.
Yeah. Okay, that will be round 4. Okay. Okay. Move left pointer. Okay, so our left pointer right now is left pointer. Okay, right now is 3. We move to the right. So now is 2, which
Yeah.
is index of 3. 0, 1, 2, 3. Yeah. Then the right point right now is equal. Right now is still the position 5, right?
Yes. Okay,
Yeah.
so we're gonna have one more check. That reminds me, I forgot to write another check. But yeah.
Okay, so right now our position is right now left num is here after we move, and the right num is here move. Then we're gonna check if this one equal to this and this one equal to this again, right? So check the what equality, I guess, with the
Yeah.
two. Okay, so which is left.
Oh, keep moving this. Yeah.
Left noun is equal to move to, and the right noun is equal to move to 2. But we don't swipe.
Ah, you found a bug in my thing. Or I found it.
That's why we need to do this one even take time. Okay,
I
we don't
see. I see better in code.
okay. And now we're gonna move pointers again, right?
Yes.
So we still move the left one first, right?
We don't. So
So the left moves.
I see now. I explained it poorly because it's not okay. So
So around the
we see our right pointer is equal to move to, so we move our right pointer to the left, and we keep moving it to the left until we find a number that does not match. That's how it's supposed to go.
I think now we should be okay. I know when we stop the round is when the index left and the index right overlapping, then we stop the round. Got
Yes.
it? So right now our left pointer after we move is index 4. 0, 1, 2, 3, 4. So it's these two. Okay. Okay, left num is 2, which is index 4. And we don't, you say we only move the right pointer left pointer first, right? And right pointer still keep at 5, right? Which is which is still 5. So that means this one, right?
Mm-hmm.
So our left after move become here 0, 1, 2, 3, 4 left, and the right is here. So we almost, so this is like the same decision as round 4. So we just move the pointer. I'm not going to write it again. So move pointers.
Yeah, I'll explain it better when I write it, because I'm like, this is not how it works.
Okay, almost finished. Okay, so round 6 is after we move. Okay, hold on. After we move the pointer, here. Okay, move the pointer right now. Yes, left now. So move left now is equal to 2, but it is in the position 5. Position 5, and the right number is equal to 2, and it's in the position 5 too. So it's overlap. That means our loop. So when it's overlap, so our loop finished, or we're gonna continue move until the j is smaller.
So we only check if it's less than. So if it's equal to, it's the same as an overlap, and then our while loop ends. Both
Okay.
while loops end.
So you say it's overlap, then the while loop end, or when the j is smaller than I, then it's end.
So all we check is that I is less than j. If I
Yeah.
is greater than or equal to, both loops
Okay.
end.
Okay. So that will be end the loop finish. So we just gonna return means we find we just got the sample output, which is this. How come the sample output is 134? But I think it's the same thing because the order doesn't matter. The order,
The
the
order does not matter for the
yeah,
non-matching numbers.
yeah,
Yeah, okay.
and here is not matter either. As long as all the twos are at the
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 end.
end. Yeah.
Yeah,
Okay,
okay.
so we finish the loop and return the muted array. Okay, so that will be that one. That's the same as this one too, Just paste here. Okay, so I think, yeah, I think your logic has no issue, right? Okay, so we're gonna implement the code, and yes, everybody understand the logic with numbers and the notes, so we
I
can do
hope
code.
so.
Yeah.
I hope it's understood.
Yeah. Okay, so we're gonna implement the code. Um. Okay, we're gonna open the notes and do the code. Okay. So Jordan wanna write code or Davian write code?
I have to explain it either way. So
Doesn't matter.
we'll see. Who, if you volunteer, otherwise I'll
Okay.
write it.
Yeah, you write it.
Who
Or
is
unless
you? Me?
So
Jordan
so
wanna write, Jordan can write. I don't
so
wanna write.
can you
Don't
guys see
write it.
my
Whatever. Yeah.
Okay, let me make sure this is
I try to write my code in an all fancy and optimized, not optimized, but just fancy way. So I'd probably best if I don't write it.
Oh, let's see. I don't have your notes. I only have. Oh wait, yeah, I do. Okay.
Yeah.
See.
Let's see.
What we got.
I do
So
the split.
step
I look at
one.
the split screen on mine.
So
Yeah,
step
that's
one.
Are these good notes, Jordan? For
Yeah.
you?
no. I don't
Okay.
think so, because yeah,
So we
I
want
don't.
to
It didn't
initiate.
quite go as I wrote it or as I had it in my head, but essentially, we'll find that out when we start writing the code.
Okay. So if you guys see anything, or what do I just like talk about or go through the steps and then write it as we go?
Uh,
Yes, you
Or
can write pseudocode like first you need 2 pointers, then you write the code. Then second, what do we do? Then you write the code.
yeah,
okay.
just some basic. You don't have to copy paste the whole
Yeah,
line.
yeah, yeah. Like the
Okay.
pseudo. Yeah,
Okay. So initiate 2 pointers,
yeah.
left and right. So let left equals 0, and let right equal array dot length -1.
Mm-hmm.
And then we're moving on. If left num. Oh wait, did I skip something? Step 2. If
Step
right num.
is
Wait.
Did I skip some?
Yeah, we
Or
need a
I'm
while.
messed
We need a
up.
while loop to determine if left is greater than right. I think you
Right.
skipped a line. Yeah,
Yeah. Where was I at though?
you were
Okay,
basically
step 1 right here. Okay.
up here, and then yeah.
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 Now you
Okay.
are doing this.
So now, while. Oops. We're here. While left is less than or equal to, or is it just less than?
Less than.
Less than. Okay.
Yeah, because when it's equal to, we're gonna exit the loop.
Yeah, we don't want to
Right.
swap it with itself. Basically, at that
Okay.
point.
Okay.
Yeah.
So then step 2, while left is equal to right, we're gonna define our first condition. Right
Jennifer,
here.
Option tab. It'll Alt tab. It'll change your life. You don't need to hit the menu each time.
Huh? What did you say?
Alt
I'm
tab.
confused.
It'll change your life with the screen brush. I promise you.
Uh,
I wish I
This
so
step
I
one.
wish I had my my actual setup in here, so I could see like your guys's the Google Meet at the same time as I'm doing it, because
Yeah, I have it on.
my
I have
setup.
2 monitors right now.
I'm not in. Yeah, I'm not in like my setup area right now. So we define our while loop, and then we're gonna put the first condition, which is if right num is equal to move 2, or we need a for loop as well?
So, in what they gave, and definitely what I'm going by, is we're just going to do an inner while loop, and then we're
Okay.
checking if the left one is equal to move to first. That's what
Okay.
we're checking.
So this one, so right here, it's if left num is equal to move 2.
Yes,
Not right.
that's what we're.
Okay.
Yes.
Okay.
If I wrote that wrong, I'm so sorry.
If left is equal to move 2.
Or I guess to move technically, since that's the
Oh,
thing
to
up there.
move. Yeah, that's.
I forgot what it was named. I thought it was Sorry, it's to move.
All good.
Mhm.
If left is equal to move 2,
So then that is
then
where we
swap.
run our. Yeah, I wrote it terribly. It's terrible in my head. So inside of the while loop, we have another while loop that checks if the value of our current. Yeah, so I wrote it wrong. It's hard to do it from memory. I need to see the code. I don't do.
Can you revise your notes?
I don't wanna. You do it. I revise notes like after it works, and then
Revise the notes so he can do the code.
I'm like I want it working. Then I write the notes. Okay.
Yeah.
All right. Fine. First thing we're
Inside
gonna
the
do.
while loop, that's good. We have another while loop. Check We don't have another while loop. Look.
Okay.
Just
So
Not yet. So look, yeah. This is why I hate my instructions. Okay, look, and I can't
also,
even
let's
do a
see,
find
where
replace. So
am I
forget
in the
that.
right spot in the instructions?
So first,
Okay, now I
we're
see.
changing that. That's the first thing. So inside of our while loop.
yeah.
So we check all inside our while loop. We check. I hate typing with this. Check to see if. Wait, yeah. The heck? If our current value is equal to 2 move. Okay. I clearly didn't know what I was writing. Shush. I don't agree with that. If it is equal to 2 move, then we start our inner while loop
Okay.
and check if our right pointer is equal to move. What the heck is this? All this stuff it's adding. Okay. If the right pointer is equal to move, we move our right pointer to the left and keep doing so until our pointer value doesn't match. Once our right pointer value doesn't match to move, we swap the positions of our current index.
No.
We swap the values of our current index and our end pointer.
No, that's not right.
What are you talking about?
So it's like a once left value equal to move to or to move, and the right num is not equal to move, then we swap positions. Need to be both conditions.
You don't. Okay.
Yeah.
Wait. So we're
So
checking the. Wait. Yo! Got it. What are we talking about? I got it right. Alright, I'm about to take off. I'm like, what is going on? So, no, this is what I'm saying. What do you, I don't know what you're saying. Our left,
right pointing. Look
what
at
is your,
your right pointing.
I know what my code look. If our left pointer is equal to 2 move, we start a while loop to look for a number in our right pointer that isn't equal to 2 move.
Okay.
Right. Okay.
So you
Okay.
already has outside condition, make sure left equal to move. Okay, got it.
Okay. So right now, where we're at, the second while loop goes. The inner while loop goes in this condition.
Yes.
Left.
Okay. And are we comparing the value of left, which would be the array value?
So actually,
To
wait,
move?
yeah. So
Yeah.
in
So
the
it'd
ifs,
be
yeah, array.
yeah. Okay, and then we start the inner while loop, right?
Yes.
Which is okay. Inside of the while loop, we check to see if our current value is equal to 2 moves. So 2. If it is equal to 2 move, then we start our inner while loop and check if our right pointer is equal to 2 move. So in our second inner while loop, we're comparing. What are we comparing in our?
Right.
If the right pointer is equal to.
Oh wait. So wait, I put that right. Oh, okay. Wait, we need. Yeah. Oh my, I didn't. Okay. So much writing. I hate this.
Is
so
it
much.
is it
Okay,
easier for you to take over, Devin?
I'm like, I'm running into like edge cases on my head that I did right. I'm like, so I gotta. Okay.
Oh, so you're
So
finding bugs as you go. Okay.
yes, that's literally what happened.
Okay.
She was going. I was like, oh wait, I found the edge case
Yeah.
that she missed because
Yeah.
it doesn't
Yeah.
run like it think. Okay. So, okay. This is I just butchered everything. So okay, it's fine. So here's what we're gonna do. So yeah, we won't do any extra variables. I don't want to do that. So at least how I wrote it, it may not be the best, but while. So now we're checking to move, and now we're checking while right is basically not. Alright, basically while right is. Oh, did I computer please? Oh. Alright is equal to move. I know it's such a stupid thing. This may not even. I'm going off memory, so I hope this works. So it basically, right. Sorry.
So if right is equal to 2.
Yeah, sorry.
If array right. Sorry if I'm just trying to think it out as you go as well. So like if the value is equal to our 2 move, that's when we move our right pointer down, right?
Yes.
Yes,
Yeah,
the
okay.
right one is equal to move to. Okay.
Right. Okay.
Then we move to right pointer. Our right point to the left.
Yes.
Okay.
And so basically, once array
minus.
right is not equal to 2 move, the while loop will break, essentially.
Right.
It'll
Right.
keep decrementing until it's no longer equal. So
Right.
when it's not equal, this is the check I forgot to put in my code. We need to do if another check to make sure left is not equal to right, because there is a chance that while looking for a match, we could end up crossing paths.
Right. Right.
Left. Are you gonna do both sign? Like something like this, like.
You know what? Yeah, let's do
So
that.
if the right number is equal to
So,
2, we move our right pointer to the left.
So if and then. Yeah, I guess we can do that. So, make it a little bit easier to read. And readability counts. Is and left is less than right.
Right. Right.
Yeah.
Yeah.
And then right minus minus.
Yeah.
Okay.
Yeah. Okay.
So while we check both of those, if both of these conditions are met, well, wait. Okay, I'm gonna have to redo how I wrote it. So
while the while array right is equal to 2 move and left is less than right. That makes sense. We want to move our right down.
No, because we still need the same conditional when we change, when we swap positions. That's why. Because we still need to check if left is less than right again when we swap positions. Because otherwise, the while loop will just break, and then it'll still run all the code below it. At least how I have it written. So until I think of a better way, which I can't off the top of my head, yeah.
Can I propose a easier solution which I see online?
Which you see online. There's a bunch of easier solutions. What are you suggesting?
Okay, fine. Just follow your logic. That's fine. So the easiest solution is you check while right number is equal to move first, then move the right pointer to the left, then check if the left number is equal to the to move or not.
Wait, check if the left number is equal to 2 move. Where?
Yeah.
In the outer loop?
No, you have while left equal smaller than right? Like the like line 27, right? Then inside that one, instead of doing this, you check while right array right equal to 2 move, then move to the right to the left.
From the right pointer to the left.
Yeah. So in our logic, we check the left first, but instead of this, we check right. We check right num first. So if the right num equal to the 2 move, then we keep moving to the left. Then until we find something is not equal to the 2 move, then we check left pointer with 2 move. Then if the left pointer is equal to the to move, then we swap. That is the online solution. But we can do the check left pointer with 2 move first.
So
Then
the
try
the
the
online
right
solution
pointer.
just switches the numbers it checks?
No, the solution. Okay, so your logic in the past or the code you are trying to write is, for example, like a line 65. Are you guys looking at? So it's
Yeah.
more like we check first left num is equal to move or not, right? So if it's not equal to move, we move left pointer to the right. Then we check right pointer right num is equal to move or not. If if yes, we move. If it's equal, so like while right. If equal, then we move right pointer to the left. But the solution I see is they check right pointer with to move first, then move left point. So check check right pointer, right num is equal to move or not. Check until we find the uh, until we find the I don't know, like, and to the left, then if the left num is equal to move, then we swap.
So essentially, it sounds like, I don't know
Until
if there's a.
find
Oh,
until find the right num is not equal to move, then we move left pointer to the right, then check if this equal or not. I don't know. Sounds like not really right.
it sounds in my head from your explanation that you're just switching which order we're checking the variables.
Pretty much. Yeah.
If I'm listening to that correctly.
The way we have it now is we're checking left first, right? And
Yeah.
The way she explained it is we check right first, then move down that way.
That's what it sounds like, and there may or may not be an advantage to that since we have to move our matches to the end anyway. But I don't know how greatly it differs, if at
Okay.
all. Basically,
Keep your logic, Davian. Forget about my proposal.
I'm just making sure I heard you right. Like based on what it sounds like to me from your explanation, you know.
Yeah.
I'm not trying to like bash or like. I'm just from what it sounds like is you're just swapping the checks around.
Yes.
which may or may not be better, but to me, as of right now, because I can't think, it doesn't matter. Basically,
Okay.
because I can't
Keep
think of anything.
keep
Oh
on
crap!
doing it. Sorry.
Don't be sorry. I was just confused. So
I tried.
I'm
Yeah.
gonna basically butcher all this code. So I might minus minus. So now uh, we need to check again if yeah left is less than right. I know my code isn't the best, but basically if less is still less than right, then we swap, and the solution had a swap function. I'm not using that. I'm going to use destructuring.
I hate how they do that.
What, the swap?
Well, like how they do helper functions and stuff.
Yeah, that's how I learned it, and then
It
I'm like, there has to
confuses
be an
me at first.
easier
Just
way.
yeah,
And then when I
like
found the destruction way, I was like, oh, that's so much better.
well, like for me, it's like I've used helper functions before, but never like an algorithm based. Like so, it confused the hell out of me.
It's it's nice because when you actually look at the how your code is running, it kind of
Yeah.
reads better, but it's harder to
hmm
think about when you're writing
Implement.
it.
Yeah.
Yeah. But it's easier to read when you're just checking over how everything works. It's like, oh, okay.
Yeah.
Like, you see a function called swap, you're like, oh, okay, it swaps the stuff. I don't need to really see
Yeah.
the logic behind that.
Yeah.
Basically, array left. I know this is probably equally confusing, but it's okay.
I'm
Alright.
more familiar with destructuring than I am with like that swap method, like that swap helper function. Array left, array right equals.
We're literally just gonna array right, array left.
Left. Okay.
Yeah. Yeah.
That makes sense.
Basically, it evaluates everything on the right, and then it changes the values on the left. So it
Right.
reads right. Array 0 is the value is equal to index right. Let's say we're now assigning the value of right to left, and then we're assigning the original value of left before we changed it to right.
Right.
So it's just how we swap positions.
hmm
I find it better than a swap. Uh,
Can I
so
ask
if
a
left,
question?
sure.
Can I? So I don't understand. I understand that here is the time to swap, right? But according to our walkthrough problem, the condition for swap the position is when the left num is equal to move, which is true because you already put here. Then and the right num is not equal to move, but you say right num is equal to move. Then you move right pointer. I understand that this when the right num is equal to move, like this one equal to this, then you move the pointer to the left,
hmm
which is right minus minus, right? Then do we need to put that condition in?
So
Or
what you're checking is so right num not equal to 2 move is essentially this. So what I'm saying is as
uh-huh,
long as the right number is equal to 2 move, as long as it is equal,
uh-huh.
keep moving the value of right to the left. So
Right.
so
Okay.
like as long as this is equal to 2 move.
uh,
Yeah.
oh,
So like this is equal to 2 move, so we move. This is
okay.
no longer equal to 2 move, so the loop breaks. And array
Yeah.
right stays at this is now this value.
Okay, got it. So when if the right number is equal to move, then we just keep on moving the index pointer until we find a
Yes.
number is not to move. Then we
hmm
run its code, right?
Yeah.
Yes.
Yeah.
So
Yes.
when it's no longer equal, the loop breaks, and then we
Uh-huh.
use that number to swap values.
Okay, then this code are running. Okay,
Yes.
understand now. Okay.
And that's why we have to check again if left is equal to right, because we want to make sure that while we were looking for a number
Mm-hmm.
that doesn't match, we want to make sure that our numbers didn't cross paths.
Getting crossed, right? Yep.
Yeah.
Because if
Okay.
they happen to cross paths, our function needs to end, and then this doesn't run, and then we basically finish, and then our loop starts over, and then that condition is false, and then we break out. Whoa, I did
Yep.
something. Okay.
Okay.
And then, so now, in this case, we're just going based off of the first loop. So
Mm-hmm.
we did this. This was equal. So our while loop moves to this number. This number does not match to move. So then we go to this code here, or we go to this line here to see if left
Mm-hmm.
is equal to right. Index 6 is not equal to index 0. It's less than. So because it is less than, we swap values. So now, based on we did the steps, da da da. So now it's this, right?
Yeah. Yeah.
So now it is this.
Wait.
So now,
So is quick question. Sorry to interrupt. Like, line 32 on the left. Are we making sure that our left and right pointers aren't crossing? We're not making sure like left is equal to right or anything.
we're just making sure it's not crossing.
Okay. I was just making sure. Okay.
Yeah.
All right.
Because if left and right are the same number, we're completely wasting a swap.
Yeah. Yeah. Okay.
So now our value is this.
Yeah.
So because we performed the swap, so as of right now,
Swap.
our right pointer is here, and our left pointer is here.
Yeah.
So what
Wait.
I'm saying is,
8.
so to help us a step, just because, I'm going to write minus minus again, because save us a step. We don't need to compare the same number twice. We already know that the value of right is equal to 2, so we're just going to move the pointer right now,
Okay.
if that makes sense.
Yep.
And like I said, in our outer, outside of our conditional, because it doesn't matter if there's a match or not. So if there is a, that's why I said we don't move the left and right pointers at the same time. If there is a match, then we want to run all this code and then swap the values. But if there is not a match, there's nothing to compare. So we left plus plus.
Mm-hmm.
Mm-hmm.
So whether or not all this, evaluation happens or not, if it doesn't match, we just want to move to the next number to the left anyway.
Yeah. Yeah.
Yeah. Yeah. Yeah.
So if that makes sense.
Mm-hmm.
So based on what I was trying to do, and then with the solution, this is sort of the combine. This is how we swap. Save yourself a helper function. I do array.length minus minus. It really doesn't matter, but to me, I just discovered that works, so I'm like, I'd rather do that.
Word. Word.
What is that?
So, and this is another reason I wanted to do this, because a lot of people don't know the difference between when the plus plus and minus minus are on either side. So when you have your incrementer or decrementer, your plus plus and your minus minus, when it's on the right side of the variable, that means it evaluates the variable as is and then increases or decreases after the fact. So it basically says while array right is equal to 2 move, right minus minus, basically, well, this example is bad, but basically it says that right is equal to whatever number we are, subtract 1, and we'll use that at the end of the loop, or when we start the loop over. When you use minus minus, it subtracts 1 before evaluation. So in this case, array.length is 7, or yeah, array.length is 7. So we want to set the value of right equal to, it's the same as saying array.length minus 1.
Minus 1, yeah.
Whereas
Okay.
if we did it like this, right would equal array.length, which is equal to 8, and then it would subtract 1 after it assigns the value. It's a piss poor explanation, honestly. But yeah, basically, the position depends on what happens when you want it to evaluate the plus or the minus. So in this case, array.length is 7. We want it to be 6. So we subtract 1 immediately and then assign the value, which is now 6, to equal right. Whereas if it was the reverse, array.length would still equal 7, and then it would subtract. But then the subtraction wouldn't matter because we don't save that value. You don't see it that often, but if you do encounter it, there is a reason for that, and that's the reason. That's why you see in for loops it's I++, because like I equals 0 if I is less than blah 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 I++. I++ means at the end of the loop you change the value. Whereas if it was plus I would equal 0, and then the rest of the loop would start at 1.
Okay. Got it.
I hope that made a little bit of sense. It probably did not.
I was following.
Can you please write this one for the older version? So gonna array. So that is equal array.length minus 1, right?
Yeah.
Okay.
Yes.
But yours are more advanced writing. Okay.
I doubt it, but maybe.
Yeah.
I just like less lines. It's not a big thing. And then so at the end of our loop, we just return
the
array.
So we can't forget that.
Yeah.
So that's more or less it. We could just structure these two. I don't care. It doesn't matter. I need to find my code. I need to find wherever I put my tab to see if this works. But essentially, that's how I would more or less solve this.
That's pretty cool solution.
I hope so. Oh, here.
Should I run it to see?
Oh, here's my code. Full screen messed me up. Okay. Yeah.
Okay, I'm gonna run this code.
Run it.
Yeah. Copy. Gonna run. Okay.
Looks good to me.
Yeah. Gonna run the code. Hold on. What's wrong with my screen? Hold on, my screen is. Okay, submit. Oh.
Oh. What is the?
Oh no. No.
There must be is there a syntax error?
No.
Do you want to run in your code to see if it's passing?
I'm running it now.
Okay, let me see if I change this will work or not. Maybe
nothing worked. Wait, program move element to end is not the function. What the heck? Oh wait,
Davian, I changed the old style. It's work now. They don't understand your new style.
They don't.
I changed to array.length minus 1. Now they understand.
Oh, they didn't. That's great.
Yeah, they are too old. You are more.
Because I tested it in the console and it worked, and I was like, "Oh, sweet! All right, I'm gonna use this." And then it didn't work. I'm like, "That sucks."
I can put this advanced. Just put minus array dot length.
I'm mad that didn't work. Oh well.
Okay. I'm gonna submit.
The console betrayed me, but yeah, okay, that worked.
Good. It works. Okay. Okay, now we're gonna do the big O stuff. Okay, gonna put here. Big O. Oh my god. Big O explanation. Okay. Hello, guys.
Hello.
Yeah.
Hello. I'm like, what's wrong? I was like, oh, you're asking us the big O now? Is that what you were asking?
Yeah.
It's a depending on the size of the input array. So let's see.
I did not check the solution for the big O, but I'm pretty sure I know.
Oh,
I hope
I have the solution. Jordan, you wanna explain this one? I'll write the notes here, line 44.
See, this is where my gray area big O like understanding is. Like I think it's linear, but like being able to explain why is like what I'm not good at.
Okay.
So I think it's O of n.
Yeah, the time complexity is
The time complexity is O of n, and I think the space complexity is constant.
right. Constant is O1, right?
Yeah.
it's O1. Wait, you're asking for space or constant? Yes,
So
constant is O1.
time is O of n, and then space is constant.
Yeah.
Yes. And you don't know the why?
No, that's like that's my one issue is like being able to explain why.
Then do you know why?
I know. Okay, but it was like I know if it's sorted array is n log n. If it's not sorted, just O n. And
So
the specificity is we didn't create an extra array or memory, so it's O1. But that's just like a very shallow explanation.
So is it because we're only traversing the array once?
yes. So
Yeah.
where is it? Okay, yes. So in the worst case, which is we don't find a match or our match is already at the end, we only we only go through the array one time to find that match or to find out there isn't a match. In the absolute worst case. Because like in our case, like the average case, it'd be log n or less than the length of the array by some fraction. So, but worst case, we go through the entire thing, but only one time.
And we always go with worst case, right?
Yes.
Yeah.
They may ask you in like if you're actually in a developer meeting and you're explaining this, and they'll want to know maybe the worst case, but then they'll want to know the average case because want to know 9 times out of 10 what's it more likely going to be, because and you may base functions on that. But for the most part, they care about the worst case scenario.
Okay.
Because if you take care of that, usually the average case is better too.
Okay, Dave,
do you understand the space is constant?
Can you please write down what you just explained in time complexity?
So the worst case, we're only traversing the whole array once. So that's why it's constant. I mean, that's why it's linear.
In our worst case scenario, our to move value doesn't exist or is at the end of the array. But in those cases, we loop through the entire array, but only one time. So our time is all then. And in our space complexity,
Mm-hmm.
it's not so much we create extra space, we create constant space.
Okay.
Meaning, so if we were to like be adding onto a new array or like doing anything else, the space complexity would change, wouldn't it?
Yeah,
Yes.
I can
Yeah.
give example like if we create hash table or 2D array, then you usually O2.
Yes.
Yeah.
So basically, because we're editing, we're mutating the array. We're not creating a new one.
Hmm.
We're only keeping track of two variables, both of which are numbers, and whether our array is 7 or 7 million, we only need to keep track of our left pointer and our right pointer. Those are the
Okay.
only. Those are the only. That's the only space we're creating. So
Right.
no matter how big the array gets, that's the amount of
You
space we
think?
need to actually run it storage wise.
Right. Right. Okay. Maybe
Okay.
I did have a little better understanding than I thought. Because like coming in, I was like, shoot, I feel like I can't like look at something and like understand why or whatever. And like now that I think about it, it makes exact like perfect sense. You know what I mean? If we're only keeping
That's how
track
I
of the two
started.
pointers, that's constant, right? And
Yeah.
then as the size of the input grows for the array on the time complexity, we're only traversing it once. So at worst case scenario, it would be linear.
It's
Yeah.
hard until it's easy. Once you get it, you're like, why was it so difficult, bro? It's
Yeah.
just you just
Yeah.
you just see it run and you think about it, and then it's like, yeah. But in the beginning, it's like, it's n squared because it's two while
Yeah.
loops. Like, no, but nice try.
Yeah. So now, but if we were working with for loops and we had like operators and stuff, that's when it gets a little different for me.
Yeah, then
Yeah.
it gets a little bit more complicated because, like in
Yeah.
this, because like at first I'm like, anytime you see an SOL loop, oh, it's squared or something. Like, no, like the other while
No.
loop doesn't really do anything. It's just like if
Yeah.
statement basically.
Yeah. Yeah. It's just a condition, right?
Yeah, it's just a giant if statement that basically says if it's not true, run again, or if it's true,
Yeah.
run again. Like we're not doing anything extra, and then the inner loop is what it is. What the actual work is being done.
Right.
Okay,
So
then can you write the explanation for space complexity?
Uh,
let's see.
Yeah, or Jordan can write down.
yeah, Jonathan get it. He
We,
sounds like he
Yeah.
understands
we
it.
are only keeping track of our two pointers, left and right. So at worst case, that's still all we'd be keeping track of. So our space complexity is constant. That good?
Okay, sounds
Works.
good. Or do you have
If you
any?
want, if you want to edit, feel free or
Yeah.
add on.
All, okay. I guess basically, uh, the amount of space, or I don't know,
Memory
we
space, yeah.
need to run our function does not change when the size of our input grows or shrinks. I guess. Yeah, that's about it. Basically.
The amount of space memory. Right. Okay. That's a better explanation.
Okay, cool. We have perfect solution now for explain that. Okay, so we finish this.
I mean, as far as I know,
Okay, so
How often do you guys do this? Just Fridays?
Fridays and Sundays. If
Okay.
yeah, do you like it or you have
Yeah.
any suggestion to improve our process?
No, I liked it a lot.
Okay.
My only complaint is that I haven't got invited more often.
Uh,
we've only had like four. Like,
I knew you were gonna react like that.
Okay, I usually drop the notes, but I don't know because we have a Slack group. I don't know how can I send the notes to Jordan. Maybe I send it to Davian. Davian can send it to Jordan.
I'm eventually gonna like create a Discord or something. I just haven't done it yet. Like,
Do you guys want to add me to the Slack group or something? Oh, I still have your number, Devin. I could text you so you have
oh
it.
yeah, that's right. You have that.
Yeah.
Yeah, it's like one of those like, it's like a,
Because our members, like the other members,
it's like a paid Slack group. That's why. So it's like
Oh, okay.
members who,
yeah they
Oh, yeah.
sometimes
You told me that.
yeah
yeah, who are like part of the program. That's so I was just like, yeah, if any of y'all want to join in this thing,
Yeah.
you can do it. And then,
they sometimes come, sometimes not come.
Okay.
yeah.
Yeah. Oh, another thing is Discord. You can, if the file too big, you drop it. You cannot download. Only Slack can download.
But
Oh,
Maybe if
you're only dropping the code though. The code isn't gonna be a big file though.
okay. Oh, you can create a Slack group.
It
You
doesn't
know.
matter. Either way, there's not gonna be a lot of messages. I like Discord because there's no message limit, but we're probably not gonna be sending a whole bunch of messages anyway. So the Slack or Discord doesn't really matter at this point. So
Oh,
I'll just
yeah.
create one or the other and invite everyone
All right.
to it.
All right. Cool.
yeah. Because right now our members are not constant. They sometimes join 1 or 2 sessions, then didn't show up. you know.
Yeah. I'm down to meet every time.
Yeah.
So
I
if you
was
Yeah.
guys
I was in
feel
another
added-
group that used to do similar things like every Sunday, and then that group died like when COVID hit because I forget why, but just when it hit, it was like, yeah, we're not doing these for right
Yeah,
now.
definitely. If you're interested, just show up on Friday. I don't know, Davian, can you confirm your Friday schedule? You say you don't like 8 p.m. to 10 p.m., right?
It's fine. It's just
Oh,
late, but at the same time, I don't know. Like when my job starts, I don't know my schedule, so I may want it earlier. But if I have to work late anyway, then I'll just leave it as is. And also, if we get some more consistent members, I would, you know, like I would keep it where it's at. But they don't be showing up, and if it's just like us two or us three,
yeah.
then
Yeah.
it can afford to be flexible. If it's like 9 or 10, then like fine.
Yeah.
Okay, so you can. So next time we should do 8 to 10, right?
Yeah.
Okay. So Jordan, if you're interested to join, just I sent you the meeting link. It always be this link. No
Okay.
brain. Yeah.
Okay.
So you just drop in the meeting. Well, every Friday 8 p.m. to 10 p.m. and Sunday 4 p.m. to 6 p.m.
Okay. Cool.
Davian, can you confirm your Sunday schedule?
We said Sunday 4 to 6.
Yeah, or you don't like 4 to 6. Because
That's fine too.
it was Howard, he like this schedule. Now he don't show up. We can change.
How you gonna like something and not be there? Oh, and I'm stopping the recording because I don't need it to be any longer. It takes forever to send to YouTube. So stopping now. Okay. It's going to stay the same basically for this week and next week, at the very least. Yeah, I hope we explained it well. Bye, Jennifer. Your screen is, but I can hear you. Uh, it's funny. The test was easy yet hard, and like I'll send you. Basically, I kind of have the questions. Wait, does it have the answers on here? I hope it doesn't. Well, maybe it does. But yeah, that one was weird. That was hard. But I have a sheet. I basically had a sheet with the actual problems that I got asked. Um, and if it has my answers, it's fine. Just figure out another way. But it's basically just a JavaScript like sheet with some of the questions they actually asked me that I'm gonna drop in here now. Yeah, 5 gigs. It's just a JS file. So here's what I was asked. I like your work, dude. But yeah, it's like there's these questions are like basic questions that they asked me. Uh, yeah, there's uh, yeah, I just left my solution in there. I'm like, why not? Yes, please. But that's what I was asked, and uh, what I found out after the fact, I solved the problem, which was great. And then I was like, this is a good blog post, how to flatten an array. And then I looked it up, like, like to see if there was anything more information I could find. And there's a function that does it for you. So, yeah, that was great to find out. So I wrote that whole algorithm basically for nothing because there's a JavaScript function that does it for you. But it's still good practice. Yeah. Yeah. Let me hold on. Let me see. It's still it's still practice. Um, I'm looking for it. Oh no, I'm in the wrong inbox. I'm gonna be working. Basically, I want to finish my blog. I wanted to finish it today, but I want to finish like adding my portfolio and stuff by the end of the week.